This is the Tabor Electronics arbitrary waveform transceiver, and this is our new radar EW primer that shows you how to use the arbitrary waveform transceiver for electronic warfare and radar applications. So let's briefly go over those. The arbitrary waveform transceiver is a system on a module. It uses high-speed DACs and high-speed ADCs to create RF signals directly. And if I open the primer here and go to this page, you can see the block diagram. So the heart of the system is an FPGA, high-speed Xilinx FPGA, and then we have 4 DACs and 2 ADCs, and both of these contain IQ modulators. We can stream data very fast across the PCIe interface, and we can create a number of scenarios. So let's go and look at what we can do. The arbitrary waveform transceiver is based on the PXI format here in our field portable chassis with a 20 dB amplifier. So we're creating some waveforms and we're amplifying them through and transmitting them through this antenna here. It's enclosed in our field portable PXE 6410 chassis, and so you can take this out onto the range, place it somewhere and create a set of emitters in the field, and then it's easily programmable using our waveform design studio with the radar plugin, so you can create scenarios or different sets of waveforms or emulations of certain scenarios with this software pretty easily. Now we've created an emitter set, transmitted it via the antenna, and then in this neighboring chassis we have a receiver antenna and we have 2 arbitrary waveform transceivers. The lower one is receiving the signal and retransmitting it, and it's currently in what we call the DERFA mode, digital RF memory mode. So it's adding Doppler and delay to the signal, and then we have it connected to the RF digitizer in the upper one, and we can look at the signal. Programming and controlling the instrumentation is very easy. It has a full programming language, and I just created a Python script here that takes the data from the received unit, and that's its top unit here, and we see that we've got some decreasing PRIs, and then it changes to a chirp, and then we take an FFT of that. There's a full digital processing system within the Proteus as well, so you can do onboard averaging and FFTs and FIR filters. So overall, for radar work, the Tabor Proteus arbitrary waveform transceiver is a fantastic tool.